The planetary stand mixer. The cornerstone of commercial dough hydration. It does not simply stir, it utilizes planetary gear mechanics. The agitator spins on its own axis while simultaneously revolving in the opposite direction around the stationary bowl. This complex orbital geometry ensures a flawless, mathematically perfect coverage of the mixing zone, systematically stretching and aligning gluten proteins without creating localized friction heat. The industrial immersion blender, engineered for localized fluid shear and emulsion. Lowering this tool into a 50-gallon vat generates an instant, high-velocity hydrovortex. The internal motor drives a shielded rotor blade at 18,000 RPM. This creates a severe, low-pressure zone, violently pulling unmixed liquids upward through the cutting head, physically shattering fat molecules into microscopic droplets and forcing them into a permanent, stable emulsion. The commercial food processor. High kinetic cellular destruction. To rapidly process dense root vegetables, raw speed is combined with exact cutting geometry. The direct drive induction motor spins a microscopic S-blade assembly. Rather than crushing the cellular walls, which releases excess water and ruins texture, the razor-sharp surgical steel exerts absolute instantaneous shear force, executing flawless geometric cuts in fractions of a millisecond. The chamber vacuum sealer. Utilizing atmospheric evacuation for anaerobic preservation. Unlike a home sealer that sucks air out of a bag, this industrial machine manipulates the entire local atmosphere. The lid closes, and a massive pump evacuates 99% of the oxygen from the entire chamber. Because the pressure inside and outside the bag is identical, liquid does not boil over. Upon sealing, atmospheric pressure is violently reintroduced, physically crushing the bag around the product. The sous vide immersion circulator, achieving absolute thermodynamic equilibrium. Traditional cooking relies on massive, unpredictable temperature gradients. This device relies on microscopic calibration. A heavy heating element and impeller constantly cycle a water bath, maintaining a precise temperature to within a tenth of a degree. This physically prevents muscle proteins from contracting past their designated threshold, mathematically guaranteeing perfectly cooked tissue from edge to center. The combi oven, the pinnacle of thermodynamic environment manipulation. A standard oven bakes with dry air. A steamer cooks with wet vapor. The combi continuously calculates and injects highly calibrated microbursts of steam into a rapidly circulating convection heat field. By precisely controlling the ambient humidity, it prevents the evaporation of internal cellular moisture, drastically reducing meat shrinkage while still driving the Maillard reaction on the surface. The commercial blast chiller, halting biological degradation through extreme kinetic thermal extraction. Placing hot food in a standard refrigerator causes localized warming and slow, dangerous cooling. The blast chiller utilizes massive compressors and high-velocity fans to violently rip thermal energy out of the product. This rapid temperature drop forces the moisture inside the food to form microscopic ice crystals instead of large, jagged ones, preserving the exact cellular integrity of the food. The Pacojet, executing micro-pruning of deep frozen matter. Standard blenders cannot process solid ice. This specialized machine requires the base ingredient to be frozen to -20 degrees Celsius. A titanium alloy blade spins at 2,000 RPM while simultaneously advancing downward on a microscopic, precision-threaded shaft. It literally microtones the solid block, shaving away layers only microns thick, generating an ultrafine, perfectly smooth emulsion without thawing the product. The Culinary siphon, utilizing pressurized nitrous oxide for molecular aeration. Creating a stable foam mechanically takes immense time and relies on structural proteins. The siphon bypasses this. By injecting N2O gas under extreme pressure into a liquid base, the gas dissolves perfectly into the fat. When the valve is opened and the liquid returns to normal atmospheric pressure, the gas violently expands, instantly transforming a heavy liquid into a perfectly aerated microscopic foam matrix. The French mandolin slicer, dictating exact geometric consistency. Knife work is prone to human error and structural inconsistency. This heavy stainless steel ramp utilizes an unyielding, adjustable runway leading to a surgically sharp angle blade. By locking the depth gauge, the chef relies entirely on forward kinetic sliding force. The angle blade executes a perfect, continuous shear cut, yielding thousands of slices with absolutely zero deviation in micron-level thickness. The Gravity Feed Meat Slicer, harnessing rotational mass and gravity for perfect yields. To slice cured meats paper-thin without tearing, shear force must be continuous. The heavy 12-inch hollow-ground blade acts as a massive flywheel, maintaining unstoppable rotational momentum. The carriage is angled at exactly 45 degrees, allowing the absolute constant force of planetary gravity to feed the heavy meat directly into the spinning blade, completely eliminating human pressure variables. The Commercial Induction Burner, generating heat through high-frequency electromagnetic friction. A gas flame is incredibly inefficient, losing over 50% of its energy to the ambient air. An induction coil uses alternating electrical current to generate a rapidly changing magnetic field. When a ferrous metal pan is placed on the glass, this magnetic field induces microscopic electrical eddy currents directly inside the steel. The pan's own electrical resistance generates instant, highly localized friction heat. The heavy-duty flat-top griddle, the master of thermodynamic mass and heat retention. Thin pans drop in temperature the second cold food hits them, boiling the product instead of searing it. The commercial flat top uses a slab of polished steel up to 1 inch thick. This massive volume of dense metal acts as a colossal thermal battery. It stores immense quantities of conductive heat energy, allowing it to rapidly vaporize surface moisture and trigger the Maillard reaction instantly upon contact. The Chinois, absolute particulate filtration by a geometric tension. To achieve sauces with a flawless glass-like texture, standard strainers are useless. The Chinois features a severely steep conical geometry made from an extremely fine woven stainless steel mesh. The steep angle forces the liquid down towards a singular point, utilizing gravity and fluid pressure to push pure liquid through the microscopic gaps while permanently trapping the smallest cellular solids. The Thermocouple Probe, instantaneous thermodynamic calibration. Analog thermometers rely on a slow-expanding bimetallic coil. A professional thermocouple relies on the Seebeck effect. The ultra-thin needle contains 2 dissimilar metal wires joined at the very tip. As the temperature changes, it generates a microscopic proportional microvoltage. The internal computer measures this electrical variance and converts it into a mathematically exact real-time temperature reading in under 1 second. The Reversible Dough Sheeter, mechanical thickness reduction. Rolling dough by hand creates uneven compression and ruins delicate laminations. This machine utilizes motorized conveyor belts to force dough through precisely calibrated, unyielding steel rollers. It exerts perfectly even mechanical pressure, uniformly compressing gluten networks and butter layers down to exact millimeter thicknesses without tearing the cellular structure. The Commercial Proofing Cabinet, biological fermentation climate control. Yeast requires exact temperature and humidity to respirate effectively. Rather than relying on ambient kitchen air, this sealed cabinet generates a perfectly stable microclimate. By injecting highly calibrated heat and vapor, it stimulates controlled exponential biological expansion of the dough, mathematically guaranteeing consistent cellular aeration. The Confectionery Guitar Slicer, multi-axis geometric shear for delicate solids. Using a knife to cut large blocks of ganache creates drag and smears the product. This heavy metal base uses frames strung with taut, high-tensile steel wire. By pressing the wire grid downward, it exerts simultaneous frictionless shear force across multiple axes, instantly dividing the block into mathematically identical geometric cubes in under 3 seconds. The Batch Freezer, cryogenic centripetal scraping. To create smooth ice cream, you must freeze a liquid base rapidly while preventing large ice crystals from forming. The liquid is pressed against a sub-zero supercooled metal cylinder. As it instantly freezes to the wall, massive high-speed rotary blades violently scrape the microscopic ice crystals off, whipping in air and generating a perfectly smooth, aerated matrix. The dough divider and rounder. Volumetric mass calibration. Manually weighing and shaping bread rolls is a massive drain on localized kinetic energy. This hydraulic press flattens the dough, then steel blades shear it into 36 mathematically equal pieces. Instantly, an oscillating base plate forces centripetal motion, violently rolling every single piece into a perfectly tense spherical structure in under 3 seconds. The commercial deck oven. Radiant thermal masonry. Standard convection air fails to create the aggressive crust required for artisan bread. This oven utilizes heavy stone or ceramic hearths to store massive amounts of thermal energy. When dough is placed directly onto the hot stone, conductive heat triggers violent instantaneous steam expansion inside the cellular structure, creating maximum vertical oven spring. The microplane grater. Photo-etched microshear. Standard graters are made of punched metal that brutally crushes ingredients, releasing bitter oils. The microplane is chemically etched surgical steel. This process creates hundreds of microscopic razor-sharp blades that exert absolute frictionless shear force. It cleanly slices the cellular walls of citrus zest and hard spices without bruising the delicate aromatic compounds. The salamander broiler. Downward intense infrared radiation. Because heat naturally rises, standard ovens are highly inefficient for rapid top browning. This specialized unit is mounted overhead. Heavy ceramic plates generate extreme localized downward infrared heat. It allows a chef to instantly caramelize sugars or melt proteins on the absolute surface of a dish without transferring conductive heat to the interior. The precision gram scale. Microgravitational load cell. Pastry relies on absolute chemical ratios, making volumetric cups useless. This digital instrument relies on the exact physical deformation of a microscopic internal metal beam. As gravitational mass is applied to the platform, the computer measures the exact electrical variance in the bending metal, calculating the weight to an unarguable 1/100th of a gram. The optical refractometer. Concentration measurement via optical variance. To perfectly balance a sorbet, the exact sugar saturation must be known. As light passes through a liquid sample smeared on the prism, the dense dissolved sugars physically bend the light waves. The internal optics measure this exact angle of refraction, translating it into a mathematically perfect Brix percentage to dictate the freezing point of the liquid. The fluted piping bag tip. Non-Newtonian fluid extrusion geometry. When piping buttercream or meringue, structural aesthetics are required. By applying manual hydrostatic pressure to the bag, viscous fat and sugar emulsions are forced through a rigid, fluted geometric aperture. This instant extrusion physically shears the fluid into structurally stable, three-dimensional architectural shapes that hold their form at room temperature. The rotary evaporator. Vacuum distillation and extraction. Boiling delicate herbs or citrus destroys their fragile aromatic compounds through thermal degradation. This machine completely lowers the atmospheric pressure inside the glass chamber, allowing liquids to violently boil and vaporize at room temperature. It extracts pure, crystal-clear flavor distillates and essential oils while leaving the molecular structure of the aromatics perfectly intact. The chocolate tempering machine. Crystal structure thermal alignment. Cacao butter is polymorphic. It forms dull, crumbly, unstable crystals when melted randomly. By holding liquid chocolate at exact, fluctuating fractional temperature curves, this machine physically forces the fat molecules to align into strong, tightly packed beta-5 crystals, yielding chocolate with a high gloss finish and a perfectly sharp structural snap. The commercial pasta extruder. High-pressure structural extrusion. Mixing pasta by hand requires high hydration. This machine uses an incredibly low-moisture semolina dough. A massive internal steel auger generates immense mechanical force, violently pushing this dry, crumbly mixture through a thick brass die. The extreme pressure physically binds the starches and shapes the structure simultaneously, creating a dense, flawless noodle. The culinary blowtorch. Localized combustion thermal shock. For crème brûlée or searing delicate proteins, placing the item in an oven destroys the cold interior. This tool rapidly fires a highly focused 3,000-degree hydrocarbon flame directly onto the surface. It forces immediate, aggressive Maillard browning and sugar caramelization through instantaneous thermal shock, while leaving the substrate directly underneath completely untouched. The commercial bone saw. High-velocity structural severing. Cleaving through dense bone with a hand tool causes splintering and massive kinetic fatigue. This machine utilizes a continuous loop of carbon steel teeth driven by a high-torque motor. The blade travels in a single, unyielding downward trajectory at thousands of feet per minute, utilizing pure linear shear force to slice perfectly through frozen marrow and dense calcium without shattering the surrounding tissue. The commercial meat grinder. High-pressure mechanical maceration. To perfectly emulsify fat and lean muscle, a blade alone is insufficient. An internal steel auger acts as a massive Archimedes screw, violently pushing the meat forward under extreme pressure. The meat is forced through a razor-sharp spinning crossblade directly against a perforated steel extrusion die. This guarantees uniform structural breakdown while minimizing frictional heat that would melt the fat. The culinary centrifuge. Gravitational separation of fluid densities. A standard strainer cannot separate liquids that are chemically bound. This laboratory-grade machine spins biological matter at up to 10,000 RPM. This creates localized artificial gravity thousands of times stronger than Earth's. It physically tears the molecular structure apart, forcing the heaviest particulate solids to the outer wall while leaving perfectly clear, pure liquid distillate in the center. The commercial dehydrator. Convective moisture evaporation. To preserve food without cooking it, you must systematically extract its water content. This machine utilizes a highly calibrated rear-mounted fan and heating element to project a continuous, even flow of warm, dry air horizontally across multiple trays. It gently disrupts the localized vapor pressure, chemically coaxing moisture out of the cellular lattice without crossing the threshold of protein coagulation. The vacuum meat tumbler. Anaerobic kinetic marination. Marinating meat normally takes days of passive soaking. This machine executes the process in minutes. The heavy steel drum is completely evacuated of atmospheric air, causing the microscopic pores of the muscle tissue to violently expand. The drum then rotates, utilizing aggressive kinetic tumbling to physically hammer the liquid marinade directly into the expanded cellular structure of the meat. The vertical sausage stuffer. Hydrostatic casing extrusion. Forcing dense emulsified meat into fragile animal casings requires perfectly controlled pressure. This upright cylinder utilizes a massive hand-cranked internal piston equipped with a vacuum release valve. As the heavy steel plate descends, it generates unyielding hydrostatic pressure, flawlessly extruding the dense matrix through the nozzle with zero air pockets, preventing the casing from violently rupturing. The digital pH meter. Biochemical acidity calibration. In modern gastronomy, food safety and chemical reactions like spherification require absolute acidity control. This delicate electronic probe utilizes a glass electrode to measure the exact electrical potential of hydrogen ions in a solution. The internal processor converts this invisible chemical variance into a precise digital readout, allowing chefs to perfectly calibrate the biological environment of their ferments. The high-speed centrifugal juicer. Centripetal fluid extraction. Extracting pure liquid from dense root vegetables requires extreme mechanical violence. The produce is forced down a chute directly onto a razor-sharp titanium grating disc spinning at 15,000 RPM. This instantly pulverizes the cellular walls. Massive centripetal force then slams the pulp against a microscopic mesh screen, violently pushing the pure liquid through while perfectly retaining the heavy, dry cellulose. The Ultrasonic Homogenizer. High-frequency acoustic emulsification. To permanently blend oil and water without chemical emulsifiers, chefs use extreme sound waves. This titanium probe is submerged into the liquid and fires acoustic vibrations at 20,000 Hz. This creates microscopic cavitation bubbles that violently implode. The sheer force of these localized microscopic explosions shatter fat droplets to a nanoscale, creating a mathematically perfect, unbreakable emulsion. The Jacquard meat tenderizer, microcellular structural severing. Pounding meat with a heavy mallet violently crushes the cells, releasing precious moisture. The Jacquard relies on microscopic surgical division. It utilizes 48 razor-sharp, double-edged stainless steel needles. When pressed into the meat, they execute clean, frictionless cuts straight through the tough connective collagen and muscle fibers, chemically tenderizing the tissue while leaving the overall biological structure completely intact. The Japanese Yanagiba, single-bevel cellular shear. Slicing raw fish for sushi with a standard double-bevel knife creates microscopic friction that damages the flesh. The Yanagiba is forged with a perfectly flat back and a single, highly angled cutting edge. This creates a purely asymmetrical wedge. As the long blade glides through the protein, the angled side gently pushes the sliced meat away, while the flat side passes through the fish with absolute zero friction. The spherification dropper box, alginate chemical encapsulation. This tool leverages pure molecular gastronomy. It features 96 microscopic nozzles. A flavorful liquid mixed with sodium alginate is pushed through the box, dropping perfectly uniform spheres simultaneously. The absolute millisecond these drops hit a calcium chloride bath, a violent chemical reaction occurs, instantly polymerizing the exterior of the draught into a microscopic structural gel membrane, while the inside remains perfectly liquid. The commercial super bag. Porous capillary filtration. Passing stock through a metal sieve leaves microscopic impurities. The super bag is engineered from an advanced, heat-resistant, non-porous synthetic polymer. It acts as an absolute cellular barricade. The microscopic woven capillaries are exactly 100 microns wide. It relies on gravity to flawlessly separate pristine, clarified liquid from microscopic biological sludge, yielding a mathematically perfect, glass-clear consommé. The commercial pass-through smoker oven. Combustible particulate infusion. True barbecue is not a cooking method, it is a chemical reaction. Hardwood is combusted in a low-oxygen environment, generating microscopic smoke particulates carrying phenols and cyrangol. The heavy steel cabinet utilizes internal convection vents to violently force these airborne flavor compounds directly into the porous surface of the meat, binding with the proteins to create a permanent, indelible chemical bark. The direct carbonation rig. Pressurized carbonic acid injection. Shaking a cocktail cannot carbonate it. This rig uses a massive steel tank holding liquid CO2 under extreme pressure. A highly calibrated regulator forces the gas through a microscopic diffuser directly into cold liquid. The high pressure physically forces the carbon dioxide molecules to dissolve into the water, chemically transforming it into carbonic acid and creating a violent, effervescent release upon depressurization.